Looking at trigonometry today, and most of this should be review. Hopefully you remember, SOHCAHTOA, sine, cosine, tangent. Um, we start out doing this only with right triangles, and so the hypotenuse is the angle opposite the right angle. And then if we pick a particular angle, the side opposite that angle, we label opposite, and then adjacent is right next to, so this is the side right next to that angle. If you pictured standing at this angle and shooting an arrow, if you shot an arrow from this angle, the side that you would hit is the opposite side. And so then, of course, we have sine is opposite over hypotenuse. You can remember that with SO. Cosine is adjacent over hypotenuse. That's ca, C for cosine, A for adjacent, H for hypotenuse. And then we've got TOA for tangent. And hopefully you've also learned the reciprocal functions. Cosecant is the reciprocal of sine. Secant's the reciprocal of cosine, cotangent, the reciprocal of tangent. So just one thing to notice there, that the cos don't go together. Cosecant goes with just sine, and cosine goes with just secant. Just make sure you keep that straight. These special right triangles, you should have learned them in geometry in degrees. So you should have learned the 30, 60, 90 triangle. And then in algebra 2, you might have looked at that on the unit circle with a hypotenuse of 1. So these are similar triangles, and so the sides are in proportion. If we divide all these sides by 2, we get this triangle here. So one of those should look familiar to you. Whichever one looks more familiar, you can work with that one. And so what we want to do is we want to start looking at these in radians as well as in degrees. And so pi over 3 is the same thing as 60 degrees, and pi over 6 is 30 degrees. So be careful with that. Over 3 goes with 60, and over 6 goes with 3 with 30. So be careful there. Remember, pi is 180 degrees. So 180 degrees divided by 3 is 60 degrees. 180 degrees divided by 6 is 30 degrees. Okay, and then you should have learned your 45, 45, 90 triangle in geometry. We want to look at that as pi over 4, pi over 4, pi over 2 now. We're going to be working with radians a lot more than degrees now. And again, this is probably what you learned in geometry. In algebra 2, you might have looked at the version on the unit circle with a hypotenuse of 1. So what we did here is we divided all the sides by root 2. And so this here, you could either look at it as root 2 over 2, or 1 over root 2. If we do 1 divided by root 2, you're welcome to do either one. You won't need to rationalize in this class. Rationalizing the denominator is just kind of an old archaic thing that we don't really need to do anymore, but some people still do. So either one would be fine here. So you're welcome to work with either version of these that you like, but you do want to be really familiar and comfortable with these special right triangles. We'll be using those a lot. Also, there are these Pythagorean triples. You don't have to know these, but they just save you some time. So if you had, for example, a right triangle where 2 of the legs were 3 and 4, you wouldn't have to do the Pythagorean theorem to find the hypotenuse. You would know that the hypotenuse would be 5. If you had a right triangle where the hypotenuse was 25 and one of the legs was 24, you wouldn't have to do the Pythagorean theorem. You could just know that the other leg was 7. Of course, there's multiples of these. So if we take 3, 4, 5, multiply by 2. We could also have 6, 8, 10. So again, if you had a leg that was 8 and the hypotenuse of 10, you would know the other leg would be 6. Just can save you some time if you know some of these, but they're not necessary. You can always just use the Pythagorean theorem. Okay. All right, so this is all kinds of stuff from geometry and algebra 2 that we should know. So we'll review a little bit, and then probably the new thing will be thinking about these special right triangles with radians. Okay. So let's say that we've got cosine of theta is 2/5, and we want to find all of these trig functions here. Okay, so we already know 2/5 for cosine. Well, if we know cosine, we also know secant. Secant is just the reciprocal of cosine. So secant is going to have to be 5/2. Right? But to find all the other trig functions, we're going to need to draw the triangle. So let's draw this triangle here, draw a right triangle. We're only working with right triangles today. And put the angle wherever you like. Okay, so cosine, ca, adjacent over hypotenuse. So the adjacent is 2, the hypotenuse is 5, and we don't know the opposite side right now. Okay, so we'll need to use Pythagorean theorem to find it. So we'll have x squared plus 2 squared equals 5 squared. So x squared plus 4 equals 25. So x squared equals 21. So x equals the square root of 21. Of course, normally we would do a plus or minus there when we square both sides. But right now we're just working with right triangles. And so a side of a triangle has to always be positive. And so we'll say that this side right here is positive root 21. So then sine is opposite over hypotenuse. So we'll have root 21 over 5. And then cosecant is just the reciprocal of that. You're welcome to just say 5 over root 21. That will receive full credit in this class, where we're perfectly happy with 5 over root 21. That's not a problem. Okay. Now, if you're an old school traditionalist, if you want to rationalize, you're welcome to. Okay. If you want to multiply by root 21 over root 21 and get 5 root 21 over 21, that's perfectly fine too, but you don't have to do that. Okay. So tangent opposite over adjacent, we'll have root 21 over 2, and then cotangent is the reciprocal. And again, you can either say 2 root 21, or if you really want to, you can rationalize the denominator. Okay. There's really no need to. The rationalizing the denominator came from the days before calculators. When they didn't have a calculator, this right side version was a lot easier to try to figure out without a calculator than this left side version. Having the square root in the numerator was easier to deal with than having the square root in the denominator. So we rationalized the denominator. We made the denominator be a rational number, and we just kind of moved the problem around. We moved the irrational number up to the numerator. But that was just for the days before calculators. Now that calculators are so prevalent, there's really, I mean, what's it matter whether the irrational number is in the denominator or numerator? There's really no reason to do so. It's just kind of a tradition that's slowly dying out. Okay? So in this class, either way, doesn't matter. All right, so here's going to be probably the new part a little bit. Let's try to do some of this trigonometry in radians. Okay, so when I say find sine of pi over 6, I'm expecting you to know this special right triangle in radians. Okay, so just like in geometry, you had to know that the side opposite 30 degrees was 1, and the side opposite 60 degrees was root 3, and the hypotenuse was 2. Now I need you to know in radians that the side opposite pi over 6 is 1, the side opposite pi over 3 is root 3, and the hypotenuse is 2. So sine of pi over 6, we look at this special right triangle. We say the opposite is 1, the hypotenuse is 2, so sine is 1/2. Okay, and we're also going to want you to go backwards. Okay, we're also going to want you to find an angle that has a sine of root 3 over 2. Okay, well, if the sine is root 3 over 2, so this is opposite over hypotenuse. Okay, well, if we want the opposite, so the hypotenuse is 2, so we're looking at this triangle here, and we want the opposite to be root 3. Well, if root 3 is the opposite side, okay, where could we shoot an arrow that would land on this side? Follow the arrow backwards, it would be this angle right here. If the angle is pi over 3, then root 3 is going to be the opposite side. And again, we're looking for radians. We want you to start getting more comfortable with radians. That's going to be all you use in calculus. Okay? So pi over 3 is the angle that we're looking for. Okay. So these questions here, we're just wanting you to look at these special right triangles, work with them in radians. So why don't you give a few of these problems a try here? Why don't you try number 2 and 3 for both directions? Try these 4 problems right here. Use those special right triangles. Right, so you can check your answers here. Most of those should have been fairly straightforward. The second 2 or 3 could have been maybe a little bit trickier. So secant, if we see a secant, the first thing I would do is switch it to what is cosine. Okay, again, these are reciprocals of each other. So if secant is root 2 over 1, then cosine is going to be 1 over root 2. And then that's something that you can find in those special right triangles. An adjacent of 1, a hypotenuse of root 2. That was the pi over 4 triangle. Okay. This third one here could have been a little bit tricky as well. So this, some old school traditionalist had rationalized this thing here. Okay. So sometimes you want to unrationalize it because none of the triangles that we had an adjacent side of 3. We had the opposite being root 3 sometimes, but we never had a side of 3 in any of those special right triangles. And so we had to kind of unrationalize this here. So you can see I did times root 3 times root 3. I mean, you could also picture this as root 3 over root 3 squared. 3 is the same thing as root 3 squared, right? And so if you think of that, you could have some of the root 3's canceling out, and that would get you to the 1 over root 3. But that's the key. You've got to kind of unrationalize the denominator. You've got to irrationalize the denominator. And then 1 over root 3, those are sides that we have in our special right triangles. Opposite of 1, adjacent of root 3. That's the pi over 6 angle. Okay? So those are the kind of angles that we'll ask you to do without a calculator, just knowing those special right triangles. When you use a calculator, the thing you just have to be really careful about is what mode you're in. Okay, so if you hit the mode button, there's either radians or degrees here. Right? So if I want to find the sine of 25 degrees, I need to make sure that I use the arrows, highlight degree, and then hit enter. Hit enter to select degree. Okay. I often even kind of recommend like you even put like a little tiny piece of a sticky note on these 3 buttons. It's like because and sometimes people get confused like, oh, when I'm doing log of something, what mode should I be? If you're doing logs, it doesn't matter if you're in radians or degrees. It's trig functions. It's trigonometry that we matter. It matters when we do sine radians or degrees. So these 3 buttons: sine, cosine, tangent. Before you hit those 3 buttons, these are the danger zone buttons here. Before you hit these 3 buttons, always check your mode. Make sure you know whether you're in radians or degrees. So maybe even put a tiny piece of sticky note on these 3 buttons to help you remember. If you're going to push those, check your mode. That's the worst way to get problems wrong on a test is you did everything right, you just were in the wrong mode. Okay. All right, so sine 25 degrees, I'm in degree mode, so I can just hit sine 25, and my calculator can find it for me. So this is about 0.423. Okay. And then how about secant? Okay. So I look for my secant button, and there's no secant button. Okay. And it's not these things with a -1 here. I know a -1 exponent can mean reciprocal, can mean 1 over, but that's not what these are. Those are going to be inverse functions. We'll talk about those in a minute. Okay. So there's no secant button. Well, what is secant? It's just the reciprocal of cosine. So what I want to do here is I want to find 1 over cosine. And then the angle stays the same. The angle's not changing. It's that I want to find 1 over cosine. I want to find the reciprocal of cosine. Okay, so I can do alpha y equals, and then 1 over, and then we're about to hit the cosine button. We're about to hit, hold on, wait a minute. Remember, before you hit one of those 3 buttons, those are the danger zone buttons. Before you hit one of those 3 buttons, what do you have to do? Check your mode. Okay, this is not in degrees anymore. Now I'm in radians. Okay, anytime you're hitting one of those 3 buttons, always check your mode. Okay, so 1 over cosine, and then 5 pi over 3, and it's just 2. Once we go over the unit circle, that'll actually be something that we'll ask you to do without a calculator. Alrighty. So now how about these problems, trying to find these values of x? And of course, we're not just asking you to circle it and say, here it is. That's one of my favorite math jokes here, find x, here it is. But we want to actually find the value of x, right? So we've got a right triangle, and so we can use SOHCAHTOA. We can use this trigonometry. Right now, sine, cosine, tangent, only good if it's a right triangle. Okay, so if we're working with this angle here, let's see what sides we have. We have the opposite side, we have the hypotenuse, opposite, hypotenuse, that's sine. So I'm looking at sine of 20 degrees equals x over 15. So we can multiply both sides by 15, get that x equals 15 sine of 20 degrees. So that would be the exact value of x. Let's find an approximation. So we're going to do 15, and then we want to find sine. About to hit that sine button. Hold on, stop, don't do it. Don't hit that sine button yet. Before I hit that button, check the modes. Well, I would have gotten that wrong. I was in radians right now. Got to be in degrees. Telling you every time before you hit those 3 buttons, be careful. Check your mode. Common mistake. All right, so 15 sine of 20 degrees. That's about 5.13. Okay. Let's see if we take a look at this one here. So if we're looking at this angle, then we've got the opposite and we've got the adjacent. So opposite, adjacent, that's TOA. So we can use tangent. We can say tangent of 55 degrees is 29 over x. And so just be careful of these ones that have the x in the denominator there. Make sure you can handle that algebra. You could picture putting a 1 under this and cross multiplying, or you could just multiply both sides by x. But one way or another, the key thing is we have to get x out of the denominator. You actually can flip both sides of the equation as well if you want. That's something you're allowed to do, find the reciprocal of both sides. Either way. So we're going to have, if we do it this way, we'll have x tangent of 55 degrees equals 29. And so then if we want to get x by itself, this tangent 55, this is all one number. We could type this in our calculator now, but it would be an ugly decimal. So let's just take this tangent 55 and divide by it, because we don't want to work with rounded decimals. Never do calculations with rounded numbers. You get rounding error. And so we've got 29 divided by tangent of 55 degrees. So we'll do 29 divided by, and then tangent now, as long as nobody ran up while I wasn't looking and changed my calculator. I think I was still in degrees, but it's always good just to double check. All right, still in degrees. All right, so 29 divided by tangent of 55, about 20.306. Okay. And notice we're not putting a degree symbol on these because these are sides. So it's only angles that need either a degree symbol if it's degrees or nothing if it's radians. Sides always have nothing for units unless there's any kind of inches or feet, of course. How about this x? So this x is an angle right here. Well, just make sure you remember the sides of the sides of any triangle have to add up to 180 degrees, right? And we know that this one is already 90 degrees here. So if we've already got 90 degrees plus this 50 would be 140. So far, we've got 140 degrees from those two angles. So if it has to add up to 180 degrees, then x has to equal 40 degrees. Okay, but what about finding this angle? Finding this angle is a little bit more work here, because we don't know this angle right here. So we're going to have to use these sides. Okay, let's try using SOHCAHTOA. Let's try using trigonometry here. So we've got the opposite side and the adjacent side. So that's tangent. But it's tangent of an angle equals a ratio of sides. Tangent of the angle equals opposite over adjacent. So right now I'm inputting the angle and I'm outputting that fraction right there. That's not quite what I want. I need to output the angle, right? I need something where I could input the 5/11ths and output the angle. Right now I'm inputting the angle and outputting the 5/11ths. So I want to switch the input and output, right? Instead of inputting this and outputting that, I want them to be switched. I want the output to become the input and the input become the output. Hopefully that sounds a little bit familiar. We did have something that does switch the input and the output, didn't we? How do we switch the input and the output? We use an inverse function. So that's going to be what those -1 things in your calculator are. They're the inverse function. Okay, so it allows me to switch this input and output now and figure out what x is. Okay, so I'm going to do second tangent. If I do second and then tangent, it'll give me that inverse tangent. I can do inverse tangent of 5/11. Okay, and I can get that x is about 24.444. Now, if you just write that, it's not quite correct. Because right now what I've written, where x is an angle, that would be 24.444 radians. Remember, I was in degrees. Well, if it's supposed to be in degrees, I have to write that it is an angle in degrees. I have to write that degree symbol there. Okay, so that could be one answer. Or if you wanted to, you could give me a radian angle. You could switch your mode to radians and do that again. And you could say 0.427. And the way that we would know that it's in radians, not in degrees, is that we would just not put a degree symbol on it. And so either one of those answers would be perfectly acceptable.